Welcome to Groundwork, a podcast from McClanahan Corporation to talk about key material processing topics, from agriculture to mining to material recycling. We'll discuss the best ways to process raw materials that power the world, because if it's not grown, it's mine. I'm Wes Edevane. Little bit of background about myself. I have been with McClanahan for nearly 11 years now. I started as an inside sales rep and was moved out into the field when I covered the mineral power and energy division. So I started with coal processing with roll crushers and everything like that. And with the market changes, I moved on to aggregate processing, fines recovery, sand processing, washing and classifying. And it's kind of grown from there. Still a regional sales manager covering several states. And I'm here with my co-host, Matt Lear, who can tell you a little bit about himself as well.
Yeah, so thanks, Wes. Yeah, my name is Matthew Lear. I'm a regional sales manager like Wesley. My history is pretty similar to what Wes was. It's about 11 years now. Started out as inside sales, and then the need went called for outside sales representatives, and just kind of out in the field, and been traveling ever since. So I specialize in wet processing, so sand cyclones, dewatering screens, fine material screw washers, all the way down to tailings management. So yeah, a little bit of everything.
Perfect. And today, I guess we're going to talk about fines recovery. So there's a lot that goes into fines recovery as a process topic, and the equipment involved, the exact process involved, and everything that kind of the ins and outs of different examples we've done in the past. And we're going to cover all that from, first, I guess we'll talk about what is fines recovery. I know that means a lot of different things to a lot of people. To me, when I say fines recovery, I'm talking about part of your sand classification that's minus 200 mesh, or normally what would be considered waste. Would you agree, Matt?
Yeah, I agree. And that's one of the big things is a lot of people don't understand when they say fines, and sometimes they mean coarse concrete sand. But a lot of times when in our field of experience, it's sub 200 mesh material. So stuff from like 200 down to 400 mesh is the fines recovery that we're going to be talking about today.
Yeah, and it can be accomplished a number of ways. I mean, really, if you can, the first thing we like to say to do is if you have a good grasp on what your specific plant process is doing. So you can't really tackle fines recovery until you know the fines that you're losing that should be in your product that aren't. And that's why we say to approach it in the way of try to find an effluent stream that's going to the pond now, specifically. Let's say a screw washer overflow that is either overloaded because over the years you've had to increase production, and there's really no other way around it than trying to get more tons on the ground. So you're feeding more tons to your screen, more tons are going through that screen to your screw washer, and that in turn overloads the screw washer, and you're left with a lot of material that should be going into your product going out to the pond. So in my opinion, and Matt, I know you cover a lot of different territories than I do, but any specific examples that you can kind of touch on to say this is what we've seen in the field, to say this when you want to test, this is what you're going to capture. So I guess we go through that process a little bit for a second.
Yeah, we kind of start there. So yeah, I mean, the big complaint that we get in the field is, hey, my ponds are filling up too fast, right? I have to muck my ponds out every 6 months, every year. And that could be a pretty expensive process to do that. So the fines recovery is a great solution to kind of recover those fines, whether they be capturable material that you want to put back in your finished product, or just fines that you want to capture and keep out of your ponds. So those are the kind of the two differences that we'll kind of cover today. But yeah, I mean, the biggest complaint that we see is screw washer being overloaded. They notice a lot of, say, plus 200 by 400 mesh material going over the overflow and going to the settling pond. So testing is kind of a critical piece that's part of the puzzle that we put together to kind of finalize a solution for the customer.
Yeah.
And the big way, I know, Wes, you've done a lot of that, is overflow Weir sampling, right? So that's kind of the biggest thing that we do in the field that can kind of tell you, hey, how much is going to waste? How much can be captured? Is it worth capturing? Is it worth putting it in your product, or is it worth just keeping it out of your ponds, right? So maybe you can touch a little bit on your testing procedures that you do.
Yeah, I think so. So let's say we approach a site and they know they have an issue because, like you said, they're looking at the ponds, they're filling up, they're going to have to muck more and more. So we'll take a sample, we'll go to the back of the weir where it's overflowing, and we'll take a representative sample that's outstretched throughout the entire length of the weir. Take that back to the lab, get a gradation, and with that, we'll be able to measure the overflow height on the weir itself, get a gallons per minute, and with those two when we do the lab testing for percent solids and the flow rate, we'll be able to tell them how many tons per hour. So let's say that we get the lab results back and they find that there's a good amount of product size material that's overflowing. So the easiest thing we can do is, we'll step right into what that scavenger system looks like. So from McLean, we like to refer to it as a scavenger system just because it's easy to explain what it's doing. It's really just scavenging material that is going to the pond now back into your product. Really what we see most of the time is you'll take the overflow from the screw washer to a sump that pumps it up to a separator that is on the last 3 flights of a screw washer. So it limits the amount of dewatering equipment that you need. You can put it right back in your product, and that really is best case scenario because everything that's captured goes into your product, so you can put it out to sell. That I would say is kind of the best case scenario for a customer to say, okay, how much material do we have? Is it worth putting in our product? And if it is, how many tons per hour increase is that going to be of our spec product to put on the ground? And that not only helps from a production standpoint, but also a return on investment standpoint, because these customers are looking at this equipment as an investment. So how quickly can they pay themselves back by putting something like this in? So, and that's really the most simplistic way to cover fines recovery from a scavenger standpoint. But Matt, I'll kind of throw it over to you to do a little bit more in depth on if it's not product sized, what do you do with that minus 200 mesh down to 400 mesh?
Yep. Yeah, and I'll touch a little bit on yours too, Wes. I guess, like you said, even if there's a couple of tons per hour, tons per hour over an 8-hour day, over a 7-day work week, right? It adds up pretty fast. So it makes a justification for something like that to be pretty easy to make. So kind of bouncing off that. So now say we go to the site, we take the overflow sample, send it back to Hollidaysburg, do our gradation down to 400 mesh. And we say, hey, most of the material is 200 minus. So that's stuff you typically don't want to put in your primary concrete sand or mason sand or whatever you're making. So that would kind of fit into an application of an ultra fines recovery, which is what we call capturing material down to say 400 mesh or 38 micron. So that's kind of what I've sold a lot of systems like that in the past, where a customer comes to us. They have a pretty optimized sand plant. It's doing a good job. It's capturing a lot of material, but their natural deposit just has an excess amount of, say, 200 by 400 mesh fines that they don't want to put in their finished product. So an ultra fines recovery system can be used to capture everything down to 400 mesh and put that onto a dewatering screen and stackable product that they can either sell, put back into reclaim into their mine, fill it. They can kind of do whatever they want with it, but it's a lot easier to handle as a dry product than as mucking it out of a pond, putting it in the back of a haul truck, spilling down the road. Just it's a lot easier to manage. So the way that works is kind of similar to what Wes said. We'd take the effluent slurry from, say, a screw washer. That would go into a sump tank, and then we'd have a pump on there, rubber line centrifugal pump. That would pump it up to high pressure cyclones that we typically use 10-degree cones. We use smaller diameter, so typically like a 12 to 15, sometimes 18-inch diameter cyclone. We have 10-degree cones, which makes them long, and we run them at high pressure. So those 3 factors increase the recovery down to 400 mesh. So by having a steeper cone angle, makes a finer cut with a cyclone, having a smaller diameter makes a finer cut, and also having a higher pressure makes a finer cut. So all 3 of those factors put together maximizes the recovery of a cyclone. So the slurry is then pumped from the sump into the cyclones. Cyclones capture everything down to, say, 400 mesh, and then they come out the bottom of the cyclones. And then it's basically 50, 60% solids by weight is typical. So it's too wet to stack at that point. So we typically put it on a dewatering screen to take it from, say, 50% solids up to 78, 80, 82% solids, which is a drip-free product, like we like to say. And that allows you to stack it on the ground and convey it. The effluent, the waste from those UFR cyclones, then goes to the existing settling pond or some sort of tailings management down the line, which I think we've done a few other podcasts about, which involves thickeners and filter presses. So It's kind of just the piece in between those circuits.
Yeah, and really to touch on that a little bit more too, that the nice part about putting that in a circuit is it can be done after the fact, because usually when you start a plant, you design it to be as efficient as possible, so you're not losing a ton of material. So when we go on site, what we see is a plant that's been changed throughout the years, that they now need
many times
some sort of additional fines recovery, and you can put this system anywhere. As long as you can. Best case scenario, you can gravity flow to it, but if you can't do that, it's easy enough to use like Matt said, a rubber line slurry pump to transfer that,
Hmm.
several hundred yards or even further away, and you're left with an area to be able to, put a radial stacker on somewhere and put that product on the ground. Now, we view it as a product. I know for a lot of customers, they're kind of left with a struggle on,
How
okay,
to
well,
sell
now we
it.
have a 200 by 400 mesh material. What do we do with it? I know in my case, a lot of the territories I cover is high calcium limestone or high magnesium limestone. Nice thing there is they can automatically turn around and sell it as a ag line product. Um, and I know there's that a lot of our customers get extremely creative when it comes to what do we do with this stuff. I mean, from my point of view, again, I've seen ag lime a lot. That's a big money maker. But I mean, you can use it as Kate fiber optic backfill. Something is pipe bedding. Matt, I don't know if you have any other examples you've seen throughout the years, but they get creative.
Yep. Yeah. It just depends how good their sales guy is, right? So if they have
Yeah,
a,
yeah,
competent aggregate product sales guy, they'll find somewhere to sell it. Even a couple bucks per ton pays for a lot of the expense of operating it. But in the overall scheme, it's still a lot less expensive than mucking it out with a long stick excavator. A lot more safe, easier to manage. I mean, the benefits are pretty significant. Um,
yeah. The man hours alone to muck that pond,
yep.
or the fact that they have to rent a long reach excavator
Hmm.
because a lot of customers don't. They
Yep.
don't have one on site. I mean, just have a piece of equipment sitting there
Yep.
just to muck. Um,
Exactly.
So yeah, you're absolutely right. I mean, the benefits go beyond that product, that new product that you're putting in,
Hmm.
and like I said, maybe you get lucky with the fact that those materials are able to put back into a money making product like a C33 sand or maybe a mason sand where you have a little bit more of the bottom end that you can sneak in.
Yep.
Um,
And sometimes it's both. So I mean, like I know a lot of your locations, they have a scavenger system with like a separator dumping onto the
mhm.
screw, and then they also have a fines recovery after that. So they're capturing the inefficiency of the plus 200 mesh from the sand plant. Then they're also capturing the 200 by 400 mesh with the fines recovery. So you can kind of be pieced together. So we actually did a pretty cool project in Michigan where we had an existing building. It was like a 4-floor story building, and they had a bunch of pieces out that were indoors, a bunch of pieces that were outdoors. So we kind of integrated our fines recovery system into their structure. So we have like on the basement, there'll be a sump that collects all the wastewater from the sand plant. Then we pump it up to the cyclones, which are on the 3rd floor, and then they flow down to the dewatering stream, which is on the 2nd floor. And then it gets on conveyors that go out on the 1st floor. So kind of, it doesn't have to be like a specific piece sitting somewhere. It can be integrated into existing systems, or it could be kind of a standalone piece that's even further away. Like another one we did where the sand plant was maybe say 2,000 feet from the pond. We actually pumped the slurry. I should say they pumped the slurry to our UFR that's actually by the pond, and they stack it there and then convey it. That way, it's out of the way of their primary production, load haul trucks, all that kind of stuff. So it can be very versatile and custom fit to what the customer needs.
Yeah, yeah, no, that's a good point because I know we've been talking about screw washer overflow a lot, and that's most common because a lot of classification equipment used in these plants is simple screw washer, maybe a sand tank to a screw, but really this can be utilized in any scenario when classification is being used. So classification and dewatering. Um, Specifically, there was a scavenger system that we put in Kentucky where we went down and they knew they had an issue. They were lucky in the way that they could pump all of their effluent flow to an unused mine. So it was just going underground. They weren't worried about it too much until they had to be, until they realized that they were losing so much product and they were filling up that mine more quickly than they anticipated. So they asked us to come out. Again, first thing we did was sample. So we get an idea of what they were dealing with. And when we got the sample results back, we were shocked to see that it was upwards of 20% solids. So there was a
It's a
lot
lot.
of material. Uh, and it wasn't classification in the traditional sense of using a screw washer. They were using a competitor's double deck dewatering screen, and it just a lot of material flowing through that, going to a sump that then was going out to being pumped underground. So we sampled that, and they knew they had an issue. I guess they just didn't understand exactly how much material they were talking. So when we put this system in, we did a little bit of modeling through our process engineering group, and we thought, let's just see what we could get as far as what they're going to be able to put on the ground and put back into their product. And it ended up being I think upwards of 30 tons an hour that they were able to put back into their product. So, I mean, obviously that's a little bit of a stretch as far as what you see normally, because I would say on average your screw washer overflow, what do you think, Matt? 5% solids is usually where it starts to make sense to look at this.
Yeah, in a good scenario, yep, yep. If you're up to 20, I mean, that stuff even has a hard time flowing out the flumes.
Yeah,
You know what I mean?
yeah,
So yeah, typically 5 to 10% is typical, but even at 10%, there's still some material that can be captured, whether that be coarse sand or ultra fine sand.
yeah, quite a bit as far as yeah, different ways to tackle it. Uh, It really all comes back to once you identify a problem and you can start to sample or call us out to sample and say, is there something we can do? There's always a solution. It's just how we go about doing it. And like I said, best case scenario, you have something to put back in your product. Worst case scenario, you're making a secondary product, but you're keeping it out of your pond. So it's really a win-win. Um, and you know, when it comes to what we can do to help a customer, in particular, the our biggest benefit is I think having the lab here on site and having our process engineers here at McClanahan be able to look at different ways to tackle the problem, because they
Oh
can
yeah.
take your current product gradation. So let's say you're using a C33 sand product. Our process engineers can look at that effluent flow and they can actually model it back into what your final product gradation is going to be. So
With a
if you're
blend. Hmm.
yeah, exactly. If you're
Hmm.
concerned with hitting an FM, if you put this fine material back in, we can use the resources we have here internally at McClanahan and model that system for you and really give you down to the ton what you would see after this is all implemented. So a little bit of plug for what McClanahan does pretty well, but yeah, really we a lot of people make this type of equipment. We realize that. I mean, there's cyclones from all types of different manufacturers, and essentially they're all the same in the way of they're a piece of equipment that uses that um, pumped material up to a cyclone to then capture an underflow. So they're making that cut, and really, I think what McClanahan does a little bit differently is utilize the process knowledge that we have and utilize the team that we have in place, not only from our dealer network, but also from internally our engineers here. But yeah, I know that Matt, you deal with a few different process engineers than I do, but in the end, they're all in the same team, and they're really working towards a final goal of getting a solution for the customer that they can really benefit from.
Yeah, and I think you touched on a really good note there, Wes. Well, I mean, I like equipment's equipment, right? At the end of the day, but like how it's applied, how it's integrated into existing systems is where we really strive for excellence. So a lot of that science is done behind the scenes that a lot of customers don't see. But like, I mean, obviously, typically we do like a flow sheet and a mass balance. Like Wes touched on that a little bit before. Where we'll tell you tons per hour, gallons per minute, how much coming in, what your feed gradation is, and then we'll also be able to tell you how much waste you're going to generate, what that waste gradation stream looks like. We can simulate all that stuff in house. So it kind of gives a customer saying, hey, if I put this system in, I'm going to capture 20 tons per hour more out of my process than I would have without it. So they can kind of justify whether it makes sense in a ROI scenario. So it just kind of goes a long way to having a lot of details. Like in the lab has also abilities, obviously, just to do gradations down to like say 400 mesh, but we also have a ability to do gradations down to say 0 micron. So we can tell actually like and that comes more into play for like tailings management stuff where we're trying to settle and thicken and press mud. Where we kind of need to see where does that clay lie? Is it mostly at 400 mesh or is it mostly at like 10 micron, right? So we have the ability to say, here's a sample, here's what it looks like, and we can tell you even what it looks like down to almost nothing. So we have a lot of ability to do the homework required to make sure the system that we supply is the right fit and the right solution for the customer.
Yeah, absolutely. And really, I think what it comes back to is that testing of the material is so important.
So
And,
critical.
and when it comes to fines recovery as a whole, just looking back at the entire process, we can say the first step is always find your effluent flow streams, whether it's a screw washer overflow, whether it's a dewatering screen
Sand
effluent flow,
tank.
or
Mm-hmm.
sand tank
Mm-hmm.
overflow. And really what it comes down to is that's your first step. So Your first step is to sample, see what you have going to the pond. Can you use it in your product? That's fantastic. If you can't, then come up with a plan on a system on how to handle that. So, going from sampling, then we give that test work back to the customer. We give them an idea of what their recoveries might be, and then we recommend: can you use a scavenger system like we talked about? Can we use, or do we have to go with multiple cyclones of a smaller diameter to try to get down to that 400 mesh and create a specific product for it? And w- honestly, there's not a limitation on how many ways we can look at this for a customer. It's just how much data can we collect to make sure that we're giving that customer the right solution for what they're trying to do.
Yep. And we can even take like different feed streams too. Like, so another application I did in, I think it was Minnesota, was they had 3 or 4 different streams. So they had a primary hydrosizer structure was one sand product. They had a 2-stage McClanahan system that was making a secondary product. Then they had like a PEP screen making like just a rinse finish product. And each one had its own waste stream. So we actually sized our system to handle all 3 streams as well as only 1, 2, or 3 of the streams. So like they could be kind of very customizable to kind of take different flow rates, and that being done with like VFDs, knife gates, things like that on the cyclones to kind of make the system more flexible to take different feed scenarios. So that in that application, they're pumping all their waste in 3 different pipelines. All 3 pipelines go into our fines recovery sump, which is pretty big. I mean, it's a 6,000 gallon sump. And I think it had a 12 by 10 with a 250 horsepower on it, feeding, I think, 4 to 6 cyclones. So it was a pretty high volume system, but it was also we were able to shut off 2 or 3 of the cyclones, turn the pump down with a VFD, a variable frequency drive, and then handle less flow. So they can kind of be designed to be robust and flexible for different scenarios. And I'm sure you've done a couple of systems like that too, Wes, where they have multiple streams and different types of feeds.
Mm-hmm.
And some
Yeah.
this month we run this mode and we're generating this fines, and
Yep.
next month we're running this mode. So they have to be, and that's where the process engineering background that we have kind of comes into play, is designing a system that's flexible for different scenarios. It's pretty critical.
Yeah. And you're right. The customers, I think, these days are just the demand for specific products can change, and they need to be able to change with the market. So they'll run a different mode, whether it's base forward or whether they're trying to, maximize eights. There's always a change. So having the ability to use the equipment, no matter the scenario they're running, whether, it's just a VFG change on a pump like you talked about, shut off a couple of cyclones, you don't necessarily have to worry too much. Is that going to be the bottleneck now in your production? That's what we want to avoid. So
Right.
I think you brought up a great point. There's no limit to what we can affect from the feed streams coming to our system. It's just having that ability to talk to our engineers to find a solution that fits best for the customer.
Yep, absolutely. Yeah, and a lot of times it changes month to month. So
Yeah. Yeah. If not
yeah,
more.
yeah. So, Wes, you touched about earlier about separator dumping on top of a screw discharge.
Yeah.
Have you? I know you've done a couple of like separators discharging into a dewatering screen after a screw. Do you mind touching maybe a little bit about that?
So yeah, especially with the ability to utilize, let's say, a McClanahan ultra dry, so it can go right into the discharge end of a screw washer to make a product that's a little bit more dry than what you would get typically off the end of a screw. So I would say, I don't know, maybe 70-ish% solids coming off the screw washer discharge, and if you need that to be drier to be able to be fed out to whether there's a customer coming in. And they don't want the water in the product itself, and you need to have that more dry. You can put an ultra dry at the end of a screw washer, and then you can utilize that separator in a way that's a little bit more efficient, because you're able to discharge it at a more dilute level than you would into the discharge end of either, whether you're stacking it on the ground,
Right.
or you're discharging it onto the end of a screw washer discharge. Because what we always say is, with the water goes the fines. So if you're able to make it a little bit more dilute coming out of the bottom, that's more fine material that's going to find its way out of the underflow rather than the overflow. So that is a pretty good benefit. If you do put something like a dewatering screen at the end of a screw, then you can discharge directly onto that dewatering screen as the screw washer product hits it, and you don't have to worry about a sloppy product going onto the belt. So yeah, I mean, we can do it that way, and we can do it, like I said, you can stack it right on the ground. We have a customer in Indiana that's doing that now. Some of the limitations there is you do have to make it more dense, and if you make the underflow more dense, you lose a lot of fines recovery. So that, yeah, fantastic example, is the more you're able to let that vacuum a little bit less on a separator, get a little bit more dilute underflow, you can capture some more of those fines. So there's always something else you can put in to benefit yourself in that scavenger system.
Yeah, our internal kind of scheme of that, as we call it, supercharging a screw washer, right? We're capturing what it's overflowing and not processing properly, and then we're dewatering the product coming out of it. So it's essentially supercharged. It's a little bit more high quality recovery and drier product. So
yeah, and really with that screw washer discharging onto a dewatering screen, like you were saying, then you even have the ability to fine tune it at the dewatering screen, where you can put in spray bars and then determine, am I going to recycle that back to the scavenger system, or am I going to let that go to a separate UFR downstream?
Yep.
So do you want to put it in your product? Do you want to keep it away from your product? And you can determine that by, letting more of that material flow through the screen and then get captured downstream by UFR. So a lot of these things can work in tandem.
Yep. Yeah, they're very, very customizable. So another thing that I kind of touch on a little bit. So a lot of times customers will purchase a UFR, they'll install it, and then their system's capturing, say, plus 400 mesh. So the minus 400 mesh, which is essentially clays at that point, is still going to their settling pond, right? So whenever it hits the pond, now it doesn't have any coarse material with it, so it kind of settled. It doesn't cause it to settle quickly. So they have a lot of like excess fines that are kind of carrying on the pond. So what some customers have done, or we've done in the past, is we'll actually supply a polymer dosing system to actually add a little bit of polymer to the waste stream going into the pond. So by the time it hits the pond, it's actually dropping off right there. They have crystal clear water within 10 feet. So there's something like that can be integrated into a fines recovery on the tail end to kind of help their settling characteristics if they are still using a settling pond. Now that also is different if they go to like a thickener and a filter press, which I'm sure we'll talk about in a different podcast, but that kind of just pieces that it kind of be pieced together. So it's not like a one solution for everything, right? Everything comes in pieces and they're kind of part of the whole puzzle. So kind of just a little interesting thing that I've seen done in the field is just add a little bit of chemical at the end and let it settle in the pond, and you get crystal clear water within 20 feet, right? So it's kind of a little trick.
Especially if they're trying to, recycle that water throughout the plant right away.
Exactly.
And although the material, the percent solids isn't as high as it was, you still see that murky water, like
clays.
Yep. So,
yep. They tend to just carry. So, yeah.
But yeah, I guess that, if we keep going downstream, there's more and more we could talk about. But I think, different podcast topics.
Yes, exactly.
But yeah, I guess really to summarize what we talked about was going back to, what do you do with that fine material? What do you do when you realize that you have a problem, whether you're filling up your ponds too quickly or you're losing too much product from your overflow? So first thing I guess we touched on, and the most important in my opinion, sample that material. Find where it's overflowing, where it's going to the pond, and sample every place you can, whether that's overflow from a sand screw, from a sand tank, even cyclone overflow, depending on how you're classifying and dewatering your sand. So that I think is the first thing. And then the second thing is let us, do some sort of process engineering work and model this out on where can you put that once we capture it? Can you put it back in your product?
Yep.
Does it have to be a separate system? And really, what does that look like? And the several examples that we talked about, obviously, I mean, we could go on and on. There's so many customers that are helped by something like this that realize that it is an issue and that maybe they just don't know how to tackle it. So I would say use McClanahan's expertise when it comes to, getting us out on site to say, is there something we can do to help? We're more than happy to go out. I mean, Matt, I know you're on the road a lot. So am I. And with our dealer network, we're able to get in front of the customers and even help sample for them, bring it back with us, do a test, and really go from there. So I guess with that, thank you for listening to Groundwork, a McClanahan podcast. Be sure to subscribe on your favorite listening app for new episodes and follow McClanahan on social media for more content. Thanks, everybody.
Thanks, everybody.